Okay, so I decided that we might need to do a little bit on capacitors here, and I thought I would start with the power supply section. We have some issues in the tone control where I'm pretty certain that it is a capacitor causing a problem, but I haven't actually checked it out yet, so I just thought, well, let's just work our way from the beginning, and we'll try and touch on everything very quickly, but we'll kind of go through the power supply section. Now, this power supply section is good for both the SHP1 and the SHP3, so if you're missing a schematic for the power supply, now would be a really good time to go ahead and print screen. Just print screen. If it's Windows, you just hold the Windows key and print screen. Yeah. And then you'll have that schematic, so you won't need to be looking about for it, especially a low quality one on the interwebs. So just very quickly, I'm sure a lot of you may know exactly how the transformers work. Now we're going to have two separate ways of connecting the transformers. We can either get 235 volts at 50 hertz, or we can get 120 volts at 50 to 60 hertz, and that's going to be the North American continent. We're definitely using the 120 volt. So once our power comes to the rectifier section, we are going to go through our first set of capacitors, and these would be known as the filter caps. So we can see that the location, or the label, is according to Seabird, is a C5165, and we have the C5166. These are both 3,000 microfarad capacitors, and I've got a little bit to mention about those. First thing is, this is essentially going to work as kind of a voltage divider. This is going to be our 0 volt reference, okay, and then this is going to be our 32 volt reference right here along this line. So you can see it goes right up to 32 volts. But then from 0 down to negative 32 volts. So because of that, this capacitor, I've seen it screw some people up. The positive leg of the capacitor is going to go towards 0 volts, and the negative leg is going to go towards the negative. So if we flip that around, well, we're going to cause a lot of problems and blow that ripple cap. So that's one of the things you need to watch out for. The C5167 capacitor is a 1,000 microfarad capacitor. This is going to be underneath the chassis. It's axial, so it just has a leg on either end of it. It is very easy to identify. They still make drop-in replacements for these. We don't have to do anything funny with them. Your larger 3,000 microfarad caps, which I'm actually probably going to suggest to upgrade those caps to something slightly bigger. We can get direct drop-in replacements. However, they look much smaller, so a lot of people will just run these directly underneath the chassis and leave the old main large filter caps on top untouched, which is perfectly okay. You just take those out of circuit and make sure nothing can come in contact with them, make sure they're discharged. As long as they're not leaking, you can just leave them just like that. We put our new caps right underneath the chassis, somewhere where they're not interfering with anything. The electrical connections are secured and they're insulated, so we don't have to worry about things bumping up against it. And sometimes you can just use a couple of zip ties, or if you want to get fancy, they actually have a board. I've seen a couple of people have made boards where they've just taken all the filter caps out and put them directly on a circuit board on some standoffs, and that allows you to just basically not touch any of the wires when you need to change those capacitors. You just desolder the caps right off of the board and solder in the new ones. So that's a pretty slick idea, and I may be using it in the future. But on the amp I'm currently working on, I just don't have time. So that's essentially the power supply section. I would suggest if you're measuring voltages and you have a plus 32 volt and minus 32 volt rail, but you're having an issue with the 23 volt rail, the very first place you should probably start is right here at this capacitor. It's a 330 ohm capacitor, and it's one of the two capacitors you will find wired directly into the chassis in most cases, unless there's been a modification done on the originals. You would see this this 330 ohm resistor right between the standoffs for these two capacitors. It's pretty easy to find. Just look between the 3,000. Follow the wires and you'll see that. So I'm going to go ahead and change the schematic, and we'll show you the next portion, which is going to be the decoupling caps, and that is where you're going to go to find hum issues. So well, give me just a second and I'll change things around a little bit. Okay, we just barely got it into shot here, but we need to talk about the next two electrolytics, and these are going to be the final two electrolytics that you'll find in the chassis, and they are in the signal chain. So They're located right here and right here, and you can see that these are actually directly connected to the signal transformers. So you notice there's a little piece of information right here behind our capacitance value, and it says NP. Not sure if we can read that from there, but it's 1500 microfarads, non-polarized, which means we don't have a positive and negative value. Now the problem is that you can't buy electrolytics that are non-polarized anymore. If you do, they're probably older, new old stock kind of a thing, and I just don't trust those kind of capacitors. They can sit on a shelf and develop IESR having never come out of the box. So it's better to just use what we can get. Well, what we can get are two audio grade capacitors that are tied together in series. That's exactly how we manufacture our capacitor, our replacements. And the way that we would do this is we would take two capacitors that are each twice the value of our capacitance, because when we tie them together in series with the two negative leads tied together and expose our positive leads so that we can tie them in here and here, we will effectively make a 3000 microfarad, a 1500 microfarad non-polarized cap, because by tying those two capacitors together, we'll maintain the same breakdown voltage, whatever their rating is. I think in this case they need to be rated at 35 volts or higher, I believe. And the capacitance value for each will be essentially cut in half. So we need to make sure that we're doubling that value. So if you take two 3000 microfarad capacitors and you tie them together at the negative terminals, then what you will have is a non-polar 3000 microfarad capacitor, which can go right across, 1500 microfarad capacitor. So I hope that's not too confusing. There's several videos out there that could probably show you how to do this, and I've already done it to this one, so we'll probably see that later. So we have basically four capacitors between these two positions, but each two of the capacitors are tied together here and two are tied together here, effectively replacing our decoupling caps. So we'll go ahead and move on to the next section. This would also, you know what, let's just go ahead and back this out. And that would probably be another good spot where you could take a little screen print. So we'll get some more of those here. So let me go ahead and change the camera, and we'll go to the preamp board and show you the tone controls. We probably won't get into the capacitors on the driver board, as it's just not really that important. It's kind of monkey see, monkey do. So give me just a minute and I'll set that up. Okay, we're starting to push against a whole bunch of different time constraints here. So let me see if we can kind of push through this just a little quicker. Essentially, and of course I've lost my pointer right out of the box. Here's another one. So what we're looking at here is the schematic for the SHP3 preamp. Now this is not the same as the SHP1. The SHP1 has some additional circuitry for equalization and scratch compensation. So that's not. This one is not going to. The SHP1 will not be covered here. This is only the SHP3. So where we're concentrating though is on we're having some tone control issues with the bass, and that would be right in this section, but not only in this section. So if we kind of follow our schematic, we can see we have a left output, and we have a high volume tap, and we've got a ground. And the way that this schematic works is we make points of contact where the nodes have a dot. We don't have the little arbitrary passovers, but this is passing over this other circuitry here. So we don't have any direct connections on most of these sections, at least not here. However, if we take a look, we do have a left output connection right here that goes through a ceramic 0.01 microfarad cap, and that goes over to our high tap. We've got a resistor here. We've got, obviously, these are more resistors and capacitors. So the capacitors that I'm going to start with are going to be in this area of the signal chain. I'm going to check the values of these, and these are going to be the polystyle caps, most of them. And then if you follow our connection, we also going past the treble section. We have some more capacitors, and those will have to be checked for capacitance values and make sure that everything's electrically connected. And those are also going to be polystyle caps. And basically, just in a nutshell, the way that these are essentially working is as pass filters. So the simplest explanation is something called the reactive capacitance is going to capacitive reactance is going to allow certain frequencies to pass or be rejected through the capacitors. So those frequencies are very specifically blocked by certain values of capacitors. So essentially, by connecting the switches to these different capacitors is going to block and allow to pass certain frequencies. That's exactly how that works. So these switches can also be a problem. I should mention that. That is the very first thing I do with these is I tear them apart and I clean them up with a small bristle brush, a copper bristle brush, and some deoxit to make sure they're very clean. And then we want to check our connections to the board to make sure that we're connected electrically. So that's already been done. I'll give it another check just to make sure it's electrically connected, but they've already been cleaned. So at this point, I'm kind of zeroing in on the capacitors, and I noticed something when I took it apart, and that's the type of capacitors that they use, but I'll get to that momentarily. But after I've checked all those in both tone control sections, I'll go ahead and kind of work my way down through the chain and check some of these other capacitors and just make sure that everything looks good and is electrically connected. We're basically looking for things that aren't functioning properly. So I'm going to go ahead and get into that, and I'll set you up with the next shot, and I will be right back. Okay, so at this point we have replaced the polyester style caps that someone had put in here, and I checked these out. Every one of them is low on capacitance value. So does that mean we fixed the tone control circuit? Maybe. Won't really know until we power it up. But I did replace them with some decent brand name capacitors that are closer in the correct value. Matter of fact, 3 of them are almost dead on. One of them is just a little out. So they're going to do much better than these, at least at blocking and passing the correct frequencies in that chain. So I did check the rest of the resistors. I checked some of the other capacitors, and nothing else jumped out as being there were a couple of resistors that were just a hair under tolerance, but they were still in spec. So again, somebody's gone and replaced a lot of these before they came here with nice metal film resistors, and all the values checked out. So one last thing I just wanted to point out about these film type capacitors. A lot of people don't realize this. There is a foil end, so if you don't know what that means, the foil end would basically be something that would be connected to the ground side. Even though they are bipolar, you can get some interference that if the caps are incorrectly, that can build up throughout the circuit, and of course that interference becomes a hum. So we want to put the foil end, and that's what these little silver markings are here. I've gone through and I've tested these to find out which end of the cap is the foil end, and we want to point those legs to the path of least impedance in the circuit. So you can check that essentially just by in this area we just put our ground to our ground probe with our multimeter to pin 3, which is our ground, and that allows us to measure each hole with the capacitor out, each through hole, and see which side has less impedance on. Of course, ground is going to be the path least impedance in this case. So we went ahead and made sure that all of our capacitors are incorrectly, so that's going to reduce or eliminate any hum that could start right there, or or excuse me, not hum, but distortion. So I'm going to go ahead and move on to the next thing. Kind of getting a little bit low on time here, and I don't want to make the video too long, so I'll go ahead and set up the camera for the next shot. So okay, so we're going to go in reverse order here for just a second. Just want to quickly go through all the electrolytics, just boom, boom, boom. So basically we have 4 electrolytics that are on the preamp board. Those are all changed, and they are in nice Nichicon caps, audio grade Nichicon caps. We've changed our polyesters that were giving us a fit. We added a couple of extra, or not extra, but there were a couple of capacitors that came in that were not in circuit. I'm not sure if you can really see them there up at the top. Those are all polys. We didn't have to change any of the ceramics. The ceramics were all good. I did have to resolder the leg on this coil right up here, right at the top, and it had broken the solder joint on the back, so that had to be dealt with. The switches at the top that you can't see are cleaned, but we've talked about those before. So if we go ahead and move up to this board right here, we'll just gently place that on the standoffs right there. Just latch one is fine. And we see that we have all new electrolytics up here, but down here, these are actually the originals. When I tested everything initially, these tested good. They had capacitance. They didn't have high ESR, but I actually have those caps right here. They will be put in as soon as I get done filming this segment. So moving down, we can see that we do have some caps that are soldered zip tied to the chassis, but you also notice we still don't have any teeth. So I'm putting some dummy caps on here. I'm looking for the hardware right now to make that happen. And these are our new filter caps. So we've actually upgraded from 3,000 microfarad caps to 4,700 microfarad caps. There was a little bit of a problem with this with bass lines kind of bleeding off the power before lighting up the dim bulbs and causing a little bit of distortion. We got rid of those. We got rid of that by adding these slightly bigger caps. So far, sounds just great. Moving over here, we have our 1,000 microfarad capacitor. That I have some of the axials, but they're not as good of a quality cap. So this one is in here. It's the correct rating, and it's going to work just fine. It just has the legs on. It's not the same style of cap. So, and then finally the decoupling, the 1,500 microfarad bipolar caps. This is what we talked about originally. You may be able to see the two negative legs are soldered together right here, and then we have the positive legs shielded and going off to our standoff on each side, and both sets have been done the exact same way. We try and shield those legs all the way through, just for grins and giggles, just to do it right. That is it. So there's been a lot of work in this amplifier. All the transistors in the preamp have been changed. All the transistors in the driver board were changed. All the FETs were changed. We didn't put brand new, I should say, 2N3055s in, but we did have to find 4 RCAs that were all the same. I like to make sure they all have the same name on the front. Do they have to? No. Do they usually have a little bit less distortion and junk and whatnot and more consistent output? It seems like it, but only if they're working correctly. So if you have 3 RCAs that are working great and 1 that isn't, you're going to have a slight difference in some power. But again, not a huge deal. We can definitely bring it to working order, but the idea here is to make people cry when they listen to it. They're not going to cry if you have one of those out. So I like it my way. It'll work either way, though. It's just my preference. So we repaired a whole bunch of wires. We had a problem with the mute trip relay that just had to get fixed. This wire actually had broke at some point, so I had to reroute that and throw some solder on there. Everything has been checked, rechecked, double checked, triple checked, and then filled out in triplicate. It is sounding great at this point. I don't really know what else to tell you. So I think what we'll do is I will probably fire this thing up and let you hear it. Of course, it's not going to sound all that great because of the compression on the camera's microphone. But I can assure you, as far as sound quality goes, the amplifier itself is putting out some pristine sound. No problems whatsoever. I would again argue that with the jukebox, we don't know what we're going to get until we plug it in and kind of adjust things out and listen to it, if the jukebox has any distortion. And also, as far as the amplification and how much sound he wants to get out of this thing. With those new transistors that we had to replace, we eliminated all the distortion. However, it's not going to be as loud as it was before. Well, this one, he's never heard it because it never played. So, but it will play now. It will play beautifully and wonderfully, and hopefully he'll enjoy it very much. So I think we'll go ahead and cut to the next segment. And if all you see is the amplifier and hear some music, then that is what I will probably leave you with. So, okay, see you in the next segment. Okay, so I've just kind of got the camera on a tripod and I've centered it right between my listening area. So again, the compression from the microphone on the camera, it's not going to sound all that great, but from my standpoint, this is distortion free. There's a slight problem with the audio control cable that every now and then it kind of loses one of the speakers, but that's in the cable, not in the amplifier. So I'm just going to kind of turn up this this music from the YouTube audio library, royalty free, which happens to be Pachelbel's Canon. I kind of would assume anybody that's ever been to a wedding or a graduation or some event where they would play this kind of stuff would know what it sounds like, so you kind of get an idea of what it's doing. So I am going to leave you with this. So I want to thank you very much for watching. I appreciate all the comments and all the feedback, and I look forward to seeing you in the next video. Thank you.